If you look at the dot structure for indigo, you can see that all of the carbons in indigo are sp2 hybridized, so they all have p orbitals, and so there is some extensive conjugation throughout the indigo molecule. But as we saw in the last video, if you're going to produce a color that's blue or indigo, you would have to absorb light that has long wavelength, and so you would need extensive conjugation, much more than is apparent in the indigo molecule. And so there must be something else that gives indigo its color, and that has to do with non-bonding electrons. And so, for example, this nitrogen over here on the left has a pair of non-bonding electrons. If this is my bonding molecular orbital and this is my anti-bonding molecular orbital, the goal was to decrease the distance between the bonding and the anti-bonding molecular orbital, or decrease the energy, I should say. And the more you decrease the energy difference between those, the longer the wavelength of light that's absorbed. And so the explanation for color in indigo deals with the non-bonding electrons that you find in that molecule. And non-bonding electrons are actually at a higher energy level than the bonding molecular orbital. And so that is a smaller energy difference between the non-bonding orbital and the anti-bonding molecular orbital. And of course, that smaller energy difference correlates with a longer wavelength absorbed. You're able to absorb in the yellow or orange region, and therefore you're able to reflect in the blue or indigo. And that is what gives it its color. And this is phenolphthalein, right, which is probably the most famous acid-base indicator. And we can analyze the dot structure a little bit. These benzene rings that are present in phenolphthalein are conjugated. But if you look at this carbon right here in the center, right, that's an sp3 hybridized carbon with no p orbitals. And so the conjugation is broken up at this carbon in the center. And so you have only a small amount of conjugation presence in phenolphthalein at a low pH. And so that's why it does not absorb in the visible spectrum, and that's why it's colorless. But we know that phenolphthalein is an acid-base indicator, meaning it's going to change color at a different pH. If you add some base to it, then you're going to increase the pH to a high pH, and then we see that it changes to a red-purple color. So we can have a hydroxide anion right here. So if I go ahead and draw in a negatively charged hydroxide anion like that, it's going to function as a base. One of these lone pairs of electrons, right, is going to pick up that proton. This oxygen had two lone pairs of electrons on it like that. And so when the base takes this proton, these two electrons are left behind on that oxygen. And so now we have three lone pairs of electrons on that oxygen, right? So now it is negatively charged like that. And so if we think about what the electrons might do, these electrons could move into here, which would mean too many bonds to this carbon. So these electrons in here are pushed off over here. These electrons would be pushed off onto here. And then again, that's too many bonds to this carbon right here. So these electrons are going to kick off onto that oxygen. So the end result would be to form this molecule over here on the right. And so there's a negative charge on this oxygen. And this other proton would, of course, be taken off in a basic environment. And so this is now negatively charged. And notice what this reaction does. It now conjugates the entire molecule. If we focus in on that center carbon, this carbon is now sp2 hybridized, which means that it has a p orbital, and we can now delocalize those electrons, right? So we now have a conjugation throughout the entire molecule. We have alternating single-double bonds throughout the entire molecule. So now, since you're more conjugated, you're able to absorb in the visible spectrum, and therefore you're able to reflect in the visible spectrum, and you're able to see a red and purple color associated with this molecule.